Welcome to our first lesson in Algebra 2. Today we are going to be discussing what is a function and what are its attributes, and then focusing specifically on domain and range. So let's go down to it. What is a function? Function is a relation between x and y, where there is no more than one y, for each x. So what might that look like? That might look like if I have a table of x and y, then if I have 1, 2, 3, sorry, that's really messy. 1, 2, 3, 4, then those y's can be anything. They can be 1, -2, 7, 1/2. That's fine. But if I have an XY table that has 1, 2, 3, 1, and I have 1, -2, 7, because this next x value has a 1, the y value has to be 1. If it's anything else, then that is a no-go. That is not a function because it does not have the same y value for the same x value. So you have to be really careful there. That's interesting. I don't know why that did that. There we go. I don't know why it's doing that. Let's go ahead and erase that. Forgive my technological issues. Still learning this stuff. Okay. So how do you test if something is a function? The vertical line test. Basically what that means is if you have a graph, something like that, and you draw a vertical line, you should only touch that graph at most one time. If you have a graph where it looks like that, and you draw that vertical line anywhere on the graph, and it touches more than once, then it is not a function. So, yes, fine. No, not fine. What is a relation? It's when one value is related in some way to another. So an example might be if I gave you some x and y's, 1 and 2, 2 and 4, 3 and 6, 4 and 8, you might notice that y is related to x because it is always double what x is. So that would be a relation. What is an ordered pair? It's a relation between x and y coordinates. And it looks like this. It's an ordered pair because order matters. X always comes first, y always comes second. You can use other variables, not just x and y, just those are the most commonly used. However, any two variables can create an ordered pair. It just depends on what variables you've defined your function with. What is function notation? So function notation is using f of x. That's how it's written and that's how it's worded. F of x instead of y. And it's showing it's showing which variable a function is dependent upon. So which variable the function is dependent upon. And you won't always see f of x, you might see h of x or r of x or r of t. It just tells you the name of the function and which variable it's dependent upon. So if you have a function that relates your revenue based on the amount of time that you work, you might have a function that is named r of t, not f of x. What is a function rule? Let's go ahead and change the color a little bit. The function rule is the rule applied to the independent variable which will result in a dependent variable's value. So the rule applied to x so that you get y, for instance. What is an independent variable? It's typically x or t for time it can change without a rule being applied. What is a dependent variable? Typically y. And its value is dependent on the value of the independent variable. So for instance, let's look at this, this example right here. What does it mean to evaluate a function at a given x? You're going to see this word, evaluate a function. And all it really is asking you to do is plug in the value of x that it's given you. So evaluate f of x equals 3x squared minus 2x plus 1 at x equals 4 is basically asking you, what is y when x equals 4? So it wants you to plug in 4. So x is our independent variable, and y is our dependent variable. The value of y depends on whatever x is. So you might see something like f of 4. This is asking you to evaluate f of x at 4. So what you're going to do is you're going to take this rule right here, but every x is going to be replaced with a 4. So we'll have 3, and then we're going to have a 4 in parentheses, and then the square, minus 2, 4 in parentheses, plus 1. So we've just replaced all x's with 4. Now we're going to use order of operations. Remember, that's PEMDAS, to evaluate what this is going to equal. So we don't have anything inside parentheses to simplify, but we do have an exponent. So we're going to apply that exponent just to the number it's on, which is 4. And we get 3 times 4 squared is 16. Minus 2 times 4 plus 1. And so we've done our exponent. Now we're going to do multiplication. So 3 times 16 is 48. And negative 2 times 4 is negative 8. Or if you'd put minus 2 times 4, you'd still get minus 8 plus 1. And then there's no division, so adding and subtracting. 48 minus 8 is 40, plus 1 is 41. So y equals 41. And your answer as an ordered pair, remember ordered pair is always x, y. So what is x? What is y when x equals that? So x is 4, y is 41 when x equals 4. That is how you answer that. So the y equaling 41 is dependent on x equaling 4. So that is the first page of our notes. If we move on to the second page, that is a check for understanding that we're doing in class. If you're watching this, you haven't been in class, or you're rewatching our lesson. So just to make sure you know what's going on, this says, determine an ordered pair for each function rule. So you can plug anything in for x, find the y that results from it, and you have your x and y for your ordered pair. So if x equals 0, then you could say f of 0 equals 2 times 0 equals 0. So when x equals 0, y equals 0. Or if x equals 1, then 1 minus 2 gives you negative 1. So when x equals 1, y equals negative 1. Or if x equals negative 2, then negative 2 over 2 plus 3 equals negative 1 plus 3 equals 2. So f of negative 2, or if x is negative 2, y equals 2. Now, it's not always going to be as simple as switching the negative. These are just turning out that way. So let's give this more advanced example. You can do this with fractions as well. Let's say we want x to equal 1/4. So if we plug 1/4 into our function rule, one-fourth times 1/4 gives you 1/16. We need common denominators to add these two fractions. So 1/16 and an equivalent fraction to 1/4 is 4/16. If you were to simplify that, you'd get 1/4 again. But now there are common denominators, so you can add the numerators. And so if x equals 1/4, y equals 5/16. So see, it doesn't always happen that it's just the negative version or opposite sign version of whatever x is. It usually does not happen that way. So that's just examples of what you could have gotten. There are literally infinite possibilities. It didn't have to be these. Attributes of a function. What are the attributes that you should look for in every function? You want the x and y intercept. You want domain and range. You want to be able to identify, if possible, the max or minimum value. And you want to identify any restrictions on y, or on x. And that might be a little bit new to you. We haven't really talked about that in Algebra 1, but there may be restrictions on x, and you want to know about those. So what is the x-intercept? It's the x value when y equals 0. It's where the graph intercepts the x-axis. If you have a linear function in standard form, like ax plus by equals c, normally you're going to see numbers there, so like 3x plus 2y equals 7, something like that. Your x-intercept is going to equal c over a. So what is the y-intercept? It's the y value when x equals 0. So you can find these intercepts by evaluating the function at x equals 0. Plug in 0 for all of your x's and you'll find your y-intercept. So it's where the graph intercepts the y-axis. So again, if you have a linear function that's y equals mx plus b, you might remember that your y-intercept is b. And you could find that if you plug in 0 for x, m times 0 is 0, 0 plus b is just b. If you have standard form, ax plus by equals c, then your y-intercept is going to equal c over b. So whatever the coefficient of y is, you're going to divide the constant by that coefficient of y. All right, what is domain? Domain is all values that x can be in a function. The domain is affected by restrictions on x. And we'll talk about restrictions on x in just a minute. What is the range? It's the same thing as domain, only it's all values that y can be. And it can also be affected by restrictions on the domain. So for instance, if your function is a function of time, then one of the restrictions on x would be that x can't be negative, since you can't have negative time. And if x can't be negative, then you can't have any of the y values that would be a result of x being negative. So the range can be affected by that. So let's talk about restrictions on x. There are three main restrictions on x that we're going to cover in this class. First, you can't divide by 0. So if your x is in the denominator, then you're going to have a restriction on x. You can't have any x value that makes that denominator equal to 0, because that would be dividing by 0. Second, you can't take the square root of a negative. So again, if x is under a square root, then there's probably going to be some restrictions there. And finally, as I just talked about, there's certain measurements that cannot be negative. Some of these measurements might be time, angle degrees, distance, area, volume. So if your x represents any of those, then there are going to be restrictions on x. And that's that page. Next page. How would you define the domain of each graph? Well, if we look at the domain of this graph, we can see that The arrow means it goes on forever in that direction, and this arrow means it goes on forever in that direction. So it's going to keep going that way and that way forever and ever. So x can be any value, because not only does it go on forever and ever in both directions, but there's continuity. It continues. There aren't any breaks. This next one, we see that there's not continuity. You cannot draw a solid curve from one point to the next. So there are breaks. These are individual points. So x can only be on those points. So we have -4, -3, 0, 2, and 7. Those are the only values that x can be on that. In this one, again, we see that there are arrows suggesting that this is going to go on forever and ever. It's not going straight up. It's going at an angle, which means it's going to keep going to the left. It's going to keep going to the right. And there is continuity from what we see. So that means that just like the first one, x can be any value. Another way to write that is all real numbers, and the symbol for that is an R with 2 lines on the back. So we're going to be talking more about how to look at different notations for domain and range. So this kind of gets you thinking about those, gives you different graphs with the domain and range in different notations. So take a look and just see what you think, see what it looks like. What do you think about it? What do you wonder? And the other activity, the other video that I'm going to make for this day is going to answer some of those questions.